Blocks are great tools that enable us to recreate similar line work rapidly. They can also contain metadata in what is called attributed blocks. A block attribute is a label or tag that essentially attaches data to your line work. Some examples of this data could be a part number, price for that part, specific comments, names, cost, manufacturer, anything you can dream of. When a block is created, you can add text to it, but that doesn't make it an attribute. You have to add attributed text to the block. They are distinctly different. Attributed text in a block can be edited and extracted by the user inserting the block. They can also be visible or invisible. When an attributed block is inserted into your file, you'll be prompted to enter in the data values that will be stored with that block. Some attributes can be constant, or some attributes can be uneditable, like a part number or a name for an example. Let's open up the attributed block example. This is a typical, very simple attributed block. It's a title block for a drawing. Right here, you can see that this is a block. All the other grips here also tell you that those are attributed fields. That means we can edit them. To edit the attributes of a block, you just double-click the block. That will open up the attribute editor. Here you have different tabs, and here you have a list. I'm going to stretch it down so you can see everything that's in our file. While this is open, I can't zoom out, I can't pan, it yells at me. So all you can do is edit the text that's in here. Now you can see the names and the text will correspond with what you see here. This is the plan tag, this is the prompt, and this is the value. This is the plan name 1, and the value is what AutoCAD will insert by default if you don't put anything into it. It's a placeholder. I come down here to the value field, and I just edit this text. As you make changes to that text, you'll see that your drawing will update. And you can change it. Type in your text, press enter, and it takes you down to the next option. Now you can see it'll type in whatever you type in. Just make your changes. And press enter and continue on. You have your sheet title, the client name, job number, designed by, drawn by, date, sheet number, and total number of sheets. So you can put in numbers, you can put in text, anything that you can put into your annotation, your text, you can put in here. If you right click, you get a cut, copy, paste, delete, insert field, and a select all type of a thing. That'll select everything in here. When you're finished, click apply or click OK, and you come out of the text editor. So that's simple. That's what's really cool about attributed blocks. And now I can copy this. I essentially can put it on another drawing. If my sheet title, my client name, my drawn by, date, designed by, project number are all the same, I don't have to reinsert or retype those bits of information into every drawing that I create. I can just copy this title block and put it in there, and most of my work is already done for me. All I'll have to do is maybe change the sheet title, and since it's not sheet number 1, it's sheet number 2. Now let me show you a little trick. If you hold down the Control key and double click on the attribute, I can edit just that one. Now, a lot of times, if you double click on it, it may or may not, though it typically will, come to the right piece of data that you want to change. So you have to type it in, click OK, and go through a couple of steps. If I'm only changing one attribute, I like to use this little tip. Well, how do you create a block that has attributes in it? That's a great question. Now, I want to caution you, it can be a little overwhelming because there are a lot of different options available to you. We'll only look at some of the basics so that you can make your own attributed blocks. To create an attributed block, all you have to do is create an attribute definition. It's sort of like creating text. only there are a lot more, variables and things to assign to it. So let's edit this block so that we can see some existing attributes, plus we'll be able to add some more into it. And you can make any block an attributed block. You just have to add an attribute definition to it. Now, normally you would double click a block to activate it in the editor. Well, that's hard to do with an attributed block because when you double click it, it opens up the attribute editor. So that trick is gone here. You have to select the block itself and then pick the block editor button or right click and go to the block editor option. So this is the title block. That's what we want to edit. We click OK. Now you can see here, it looks a little bit different because some of these are really expanded out. But if I look at one of these attributes like sheet, double click it to edit it. And you have three main points here of interest. One is the tag. That's the name of it. That's what it's called. That is an identifier for that attribute. The second one is the prompt. So if you use the insert command to insert an attributed block, it will prompt you to fill in each one of these attributes. And this is what it will tell you. Hey, this is the sheet title. And then by default, it will put in sheet title if you just press the enter key. Let me show you that before we go any further. So start the insert command. We're going to go to the title block. It's the only block in the file, so you'll be okay. Now I want my scale to be at 1. We're going to specify the insertion point on screen. Everything else is okay. Click OK. Now, this block is a little bit bigger than the others, so evidently those have been scaled down. That's okay. We're going to find our insertion point. For right now, just put it anywhere in the drawing. And while you're inserting your block, you can use your mouse with your scroll wheel to zoom in or out, or to click and hold it so that you can pan around. It's very useful. Pick your insertion point. Now, the block didn't disappear, it's just not completely in yet. It's asking you for the plan name. Remember, we looked at it and it said what plan name 1, plan name 2, or the sheet title. Well, here's the tag is plan name number 1. The prompt is plan name, and the default of what it's going to enter is plan name. Now we're going to give it a name here. We're going to call it my drawing. Press enter. And now it goes down to the next attribute. This is plan name number 2. Say, I made this. Enter. And it goes down the list. Client name, we'll call it XYC or XYZ. Client name 2. You can leave one blank. Just press the space bar. Job number. Or you can just press enter and it will just put in the default field information and just go through there. So this client here, client number 2, if I want that field to be blank, I edit it, put in a space, and it's blank. And that's the same case with any of these. So that's what it looks like when you insert an attributed block. So let's pick it and let's learn how to make our own attributes. Click OK. Now we have all of these attribute fields here. This object is just regular text. It's static. Once it's inserted, it's not going to be changed by the user. However, this job number is an attribute definition, and you have your properties manager palette, which can make some changes to it. You can change the tag, you can change the text style, the value that it's going to default, justification height. It works and looks just like text. So let's create a new one. If I want to create an attribute definition, I have to come here, pick it, and this is the little window that you get. You can make it invisible. So, well, why would I want to do that? Well, you can assign a value. Maybe it's to count something, or maybe it's a serial number for a part, but you don't want that number to show up on the drawing. That's very likely. So you can make it invisible. You can make it a constant. That gives it a fixed value for block insertions. That means it's not going to change. You can put a verify prompt on here and it will prompt you to make sure that the attribute value is correct when you insert the block. Now that could be very useful. It can also be very annoying. So it just depends. Do you want to have to do everything twice, or Do you want to make sure that you did it right and you don't want to have to go back? That's up to you. Now the preset option will put in a default value when you insert a block. So it won't even ask you or prompt you to insert something. It will just automatically insert the default setting. You can lock its position so that it can't be moved. It can be on more than one line, etc. So you pick your insertion point. You're going to pick it on screen here, and we have to define the tag prompt and default. Let's say we want to know who designed this. We have a checked by, we have a drawn by, but we don't know, maybe someone else designed the project. That'll be fine. So let's say designed by. We'll put in the prompt. A lot of times, these are just going to repeat themselves. And the default, let's say designer. Now, if you click here, we can insert what's called a field. A field is a little bit more advanced for what we're trying to do here real quick, but essentially a field will look into the drawing and gather information for you. So if you have a hatch pattern or a closed polygon and you need to know the area of something, you can tell the field to, hey, look at the area of that specific object and put that information here in my attribute. And that's really cool. Now you have different text settings. Your justifications, left, align, fit, center, etc. We'll just stick with left. And the text style, go with notes. Is it going to be annotative? Not in this case. And how high is it going to be? The text height, well, that's defined here by our text style, so we don't have any control over that. You can even have it rotated. Once you get all these settings the way you want, you click OK. And if you've put spaces in your tag, well, it's going to yell at you just like it did to me. So you have to go to your tag, and what you can do instead of a space is to put an underbar or a dash or something. Click OK. And now we find a place here to put it. This really isn't designed for something like this, but that's okay. I'm just going to place it right there, and there we go. Now it's on whatever layer I've set it to. Layer 0. We may want to match the layers here, or we may just want to change everything to by layer. For right now, I'm just going to leave it. When we're done, we can test the block out, see what it looks like. Say, there it is. It says designer right there. Now when I double click on it, is it going to be an option? Yes, it is, and I can change it all that I want. That's fantastic. The block works properly. Click close. And then click Close Block Editor. Yes, save the changes. And wait a minute, where did it go? It's not there. It didn't work. Well, this gets kind of tricky. You're going to have to use something here that's a block attribute manager. Now, don't laugh when I tell you the name of the command or what you're going to type in for it, because it really is a command. And it's one of my favorite commands to tell people about because they don't believe me when I tell them it. The command, what we need to do, will automatically update all the instances of an attributed block so that it matches the changes that you've made. Otherwise, it's going to stay the way it is. All right, the command you need is Batman with 2 T's. BATTMAN. That's the Block Attribute Text Manager. It's a mouthful. So you see here, it gives you a list of the types of blocks you have in your file. We want to update the title block. And we get a look at it, say, yeah, this is fine. If I want these to be in a different order, it's meaning not where it's going to be on the screen, but meaning on how you're going to be prompted for them when you insert the block. So if you want any of these to be different, like maybe we want the sheet title to be the first one. Select it, click Move Up. So now, when we insert it, the sheet title, which is probably more appropriate, will be prompted first. Since we've added in this new attribute, we need to sync all of the other instances of the block. So click the Sync button. Move this out of the way, you'll see it fixed it. You can click Apply, click OK. And that's been fixed everywhere. So those are attributed blocks. They're very useful. If you're creating a site plan for a residential area and you need to create the storm drainage pipes or the storm drainage structures, you can create a labeled attributed block that will ask you to put in a part number, or hey, this is the number or the designation for that structure. It's structure 7 or structure E4, etc. And so that's a great way that you can do something very quickly by creating that block and then adding it to a multi-leader so that you can very quickly label and mark your structures or whatever type of item it is that you need to label. Sometimes you need to take an existing block and modify it into a new block, but without messing up the old block. So the explode command can help. Open up the annotation drawing file. Make sure you go to the Model Space tab. The explode command explodes a compound object when you want to modify its components separately instead of editing the block. That means it breaks it down and turns it into all of the basic instances or objects that it's made of. So if we copy one of these chair blocks, we'll put it anywhere on our file. And if we explode it, now your explode command is just explode, or you can type in the letter X for explode, or as usual, it's right here on the ribbon. Go to the Home tab, Modify panel, right here, explode. Pick the object, press Enter, and there you go. These blocks are still intact. This is basic line work. We have a few ellipses, polylines, etc. Now the explode command will also explode other types of objects like polylines. It will break them up into their basic objects, like in this case a line and an arc. This polyline was only one type of item, but it turns it into an arc. You can also explode multi-line text, and that will turn those into single-line text. There are instances when you may want to do this, but typically you're not going to. Now that we have this chair exploded, we can make some minor changes. Generating new line work, but yet similar to our old line work. Doing a lot of the work for us already, so that we only had to make a few modifications. And now we can make a new block. We can call it Chair 2. Pick our insertion point. Pick our objects. And there we go. And now when we go to insert a chair, we have two options. We have chair and we have Air 2. I mistyped in the name. That's fine. If you do create a block and give it the wrong name, let me show you a trick. Use the rename command. Go to the blocks. Here's Air 2. Puts the name here. That's the current name. And give it a new name. Chair-2. There you go. Everything else is the same. It's a block, and it's called Chair-2. There you go. So that's why you would want to explode something like a block. Now let's look at something else. Let's open up the attributed block example. Now in this case, we have an attributed block. What happens if we explode it? Type in the letter X for explode, press Enter, select the block, and enter again. Wow, we lost all the information in it that we had. And it's now an attribute again, but when you double click it, these are the fields you get, just like when you created the attributes. Well, if that's what you're looking for, then that's okay. But a lot of times you don't want to do that. In fact, most of the time you don't want to ever really explode a block, especially an attributed block. Now let's undo everything. I want to show you something. All of these attributes have text put into them. Let's put in something special too. Change a couple of them. Something special. Now if we explode it, we lose that. Okay, undo. I want to show you a different command. It works very similarly to the explode command, But when it comes to attributed blocks, it will retain the values you've inserted, and it's called burst. Press enter, select the block, press enter again. There you go. Say, well, it doesn't look any different. Sure it does. Look, that's just a line. This sheet title is just single line text. And that something special that I put in just for you is still there. So if you need to explode an attributed block for some reason, think about it for a second. What are you trying to achieve? Do you want to keep the values that you've put in there, or do you want to just lose it all? If you want to keep it, use the burst command instead of the explode command. Blocks are very useful, as we've seen. They're pretty straightforward on how to create, and you can do a lot of different things with them. We've looked at static blocks, and we've looked at attributed blocks, but there's another type of block called the dynamic block. A dynamic block is flexible. It's dynamic. It means it can change. It has intelligence built into it. They can easily be changed to display different line work very easily in a drawing. We've looked at some of them already in the previous sections and chapters, but I want to look at them a little bit more closely. Now, we're not going to cover every aspect of them because they're too complicated right now, but we're going to give you a brief introduction so that if you come across them, you'll know how to use them, and you'll know how to make some of them, very basically anyway. Dynamic blocks make it so that you can customize a block instance to fit different needs. For example, let's say you needed a door that's 30 inches wide. Well, you'd have to make a block that's 30 inches wide. No big deal, right? Well, let's say that in the same project and in the same drawing file even, you needed a second door that had to be 32 inches wide. So that's okay. Copy it, stretch it up a little bit, save it as another block. So now you have 2 blocks. Well, let's say now all of a sudden the client has a special request and they want one that's 36 inches. Well, now you've got to make a third block. And then now let's say, well, you know what? All those 36-inch doors, I want them to be 34-inch doors. You have to change them. So you have to delete them all, reinsert. That's some extra work. But if you had a block in there for that door that was already a dynamic block, then you could design it so that it would fit all of these needs, but with just one block. That would help you to make the changes very quickly. It also makes these blocks more useful since one block can fill many needs. Let's open up the annotation file. Yes, I know, we've looked at it several times, and in fact, we're going to draw this whole file from scratch here as our final project. So you might want to take a good look at it. Let's go to the Model tab. Here we have several different types of blocks. We've looked at our chair block, and we've looked at some of the others. The door and the window block are both dynamic blocks. So you've used them and you just didn't even know it yet. The door block does exactly what I described to you before. It's set up right now to be drawn at 3 feet, but if I click this grip and I stretch it, it can go to 3 foot 4 inches, just like that. I can take this door and bounce it back, and I've completely redesigned these doors with just 2 grip edits, and I'm done. It is that simple. I can change it to a 2-foot door for skinny people, or I can put it back to where it was at. Otherwise, I'd have to recreate all the line work, stretch some things, move some things, rotate some things, etc. That's what a dynamic block will do. Now, there are a lot of grips on this door. This one here will change the opening. It'll make it closed, put it at 60 degrees, 45 degrees, or all the way open to 90 degrees. Now, this gives me a lot of options. So I can show some doors wide open. I can close other doors. And I only have one block. Otherwise, I'd have to do a lot of rotating and moving, etc. Well, I don't have to because I can use dynamic blocks. Now, the window block is very similar. I can change the width of the window to a lot of different options. And all of these options that are here can be designed into the block itself. I can even make it so that it stretches this to any distance that I want. I can flip the block's orientation. I can change the width to match a more narrow need. Or I can move it to wherever it needs to go. So there are a lot of different things that you can do with dynamic blocks, and I'd really love to show you how to create them, but they're kind of complex. Think of it this way: making a dynamic block is sort of like creating a computer program, but for geometry. Maybe it's not really that complex, but it is similar. Autocad comes with several dynamic blocks in them. If you press Ctrl+3 to open up your tool palette, you'll have access to a lot of them. If you click on the Structures tab right here in the tool palette, any block that has that little lightning bolt on it means it's a dynamic block. These blocks here, they're not. But this beam is. Insert it, select it, and here you have a choice of all of these different types of wide flanges. Just pick the one you want, and it's drawn to spec. The I-beam and the channel work basically the same way, and they have imperial and metric examples in here. If you come down to some of the others, if you right-click on here, we can go to the architectural tool palette. Here's the door that we inserted. To insert it, just click it, and then find the place where you want it to go. Once you have it where it needs to be, you can use your dynamic blocks to flip it around, put it upside down, and close the door. Here's another one for some windows in an elevation view. And this one will stretch it out widthwise and height-wise. So these are great ways to very quickly draw things. Some of them will stretch and move around, flip doors open. Others, in the case of this toilet, if you pick it, it'll flip it from side to side, or you have options of different design types and in different design views: your front, your plan view, your side view. Now, it does take time to draw all of these up, create the dynamic block, but once it's done, it's done. And now I can have 3 different designs for these toilets, all of which are shown in 3 different drawing views. So dynamic blocks will give you flexibility. They're dynamic. They can do a lot of different things, and AutoCAD has several of them. And in fact, if you need more, you can look for dynamic blocks on the internet somewhere. Save them, use them all over the place. Blocks help us reuse line work in our drawings. For this chapter's project, we're going to use the project template file. We're going to add 2 blocks into the file and make a 3rd one to use in a later project. Open the project template file that you created earlier. I've put a copy of the project template file in this folder for you, or you can use your own. You should be using your own, but just refer to mine so that you can make sure that we're on par, that you've got everything the way it needs to be. Okay, so far in this, we created a new file. We used the regular template that we had. It has a title block in here for us to use. We've established and set up layers, changed some of the existing layers. We've created dimension styles. We've created text styles. So we're really building the base for our new drawing that we're going to create. So now we need to make some blocks, and we need to make sure we have blocks in here. Go to the Model tab. There shouldn't be anything in here right now. It should be a nice empty space. Open up the tool palette. Do that by pressing Ctrl and 3 at the same time. Go to the Architect tab. If you can't find it on here, that's okay. Remember, come down here to the bottom left, right click, and all the tabs that are available to you will be listed. Find the architectural one, pick it, and it'll open up. Now we need to find the window block. This one right here. Except that's the metric. We're going to be working in imperial units. So scroll up, grab the imperial window, pick it, and insert it. There we go, it's in our file. This will insert the block from the tool palette and put it into our file. You can place it anywhere from now. Now let's do the same thing with the door. We want this door right here. Pick it and insert it. Okay, now we're going to use these two blocks in our template file much later on. We've added them to it. We can erase these, in fact, and they're still in the file. If you type in the insert command, click OK, click on the arrow, and you can see here that we have the door and the window. And we can put them in our drawing. So they're here now. That's great. Now, we need to get the chair from our annotation example file. So go to the annotation file, pick it, open it up. Now we're going to W block out our chair. Pick the block that you want. So we select block because it's already in here. Find chair and find the folder you want to save it in. If you want to save it in your cloud, that's fine. If you want to save it in your chapter, go right ahead. Let's call it chair-project. That way we know it's the chair for our project. It's in inches, that's good. Click OK. All right, we exported this block from our file here. Now we can use it wherever we need to. Press Control and Tab. That'll take you to our project template file. And remember, at the top of the screen, if you read it, it will tell you what file you're in. Now let's put this in our file. Insert, enter, browse, go to the proper folder, find the chair-project file, click open. All we need to do now is insert this into our drawing. Now we've inserted our chair. Well, we want to make a change to it. So select it, right click, go to the block editor. We want all of this line work to be on layer 0. So make that change. Select everything, then go to your properties palette and change everything to layer 0. Once done, pick the close block editor button. Make sure to save the changes, and now you can erase it. Okay, we just saw two different ways to get blocks into our drawing. So that's fantastic. We pulled some in from our tool palette, and then we went to another file and essentially extracted the information out of it and put it into ours. Now let's make a new block. We're going to make a plant. So let's draw a circle. You can draw it anywhere on your screen. Give it a 6-inch radius. Offset that by 1 inch. There we go. Now let's draw a polyline from the center. Type in PL for polyline, or you can get all these commands up here in the Home tab in the ribbon. Start it from the center. Hit F8 to go straight out. Let's go 3 feet. Turn off the ortho again and just draw a short line, say 6 units, just about anywhere. Hit A for arc. Type in NEA for near, and we're going to drop it in right there. Now, type in MI for mirror, and mirror this block right there, about this line. Don't delete it, and there's a nice little leaf. Let's use another command that we've done in the past. That's the polar array. Select the objects. That's both of these sides of the leaf. Press Enter. Specify a center point, which is going to be the middle of this part. And then let's figure out how many we want to use on here. Let's see, right now there are 6 items. What happens if we do 3? Does that look okay? Let's go with 3. If that's the way you'd like it, close the array, and there we go. There's our plant. It's a nice big giant leafy plant. Let's make it into a block. So type in the word block, press enter. Let's give it a name. Let's call it plant big leaf. Now let's pick our base point. We want to go to the center of our pot. And we want to make sure we've picked all of the objects. We want all of these into it. Set to inches, good preview. Okay. And there is our new plant. Let's erase it. And we can do a quick double check with the insert command to make sure we have our title block, chair, a door, big plant, and a window. Cancel out of there. And there we go. So now we've inserted blocks from 2 different sources, one the tool palette, one from another file, and we've created a new block. So we're getting close to having our template file ready and having all the tools set up so that we can create our drawing at the end. Autocad is a computer-aided design drafting program. It's here to help us create construction documents. In order to do so, we have to create a geometric database or a model. It can be a group of either 2-dimensional lines or even in AutoCAD a 3D solid model. Once the modeling is complete, we have to annotate it to display it to others and to show them what its features are. Let's open up the mechanical example file. AutoCAD is organized into 2 different working environments or spaces to help us accomplish the creation of our documents. They're represented by Model Space and the Paper Space tabs, as seen here on the bottom of my screen. Sometimes these tabs can be hidden, appearing instead as buttons on the status bar at the bottom of the application window. So if you don't see these tabs, you can turn them on by right-clicking the buttons and clicking to turn them on. They should be right here, Paper and Model. Also, if you go to the Options window, there is a layout element here in the Display tab, and it says Display Layout and Model tabs. If I turn that off, they go away. Let's turn them back on, and I suggest that you use them. Leave them turned on all the time. Typically, a model is composed of geometric objects, and it's created in a 3-dimensional space called model space. In AutoCAD LT, it's only a 2-dimensional model space, as we see here. A final layout of specific views and annotations, like text and dimensions and things, of the model will be created in a 2-dimensional space called Paper Space, or the Layout tab. These spaces are accessible on 2 or more of the tabs near the bottom of the drawing area. We have Model and Layout. Working on the Model tab, you will draw your model or your line work, and the subject of your model will be drawn at a 1-to-1 scale. So in the case here, this is drawn at 3 inches. So this little flywheel that will be constructed will actually be 3 inches wide. Each layout has a picture in it, or a frame. It's called a viewport. This viewport gives you a photograph of the model that's in model space. Think of it as a window peering into model space. Each layout viewport contains a view. It displays the model at a specific scale and orientation, and you can specify what those are. You can also specify which layers are visible in each layout viewport. After you finish arranging that layout, you can turn off the layers that contain the layout viewport objects. Alternatively, you can also set the viewport layers to a no print setting so that these rectangles or squares won't be visible when you print it out. In either case, the views are still visible. So the line work that it's showing, of our flywheel here, you'll still be able to see those when printed, but these big ugly squares, they won't be. That's really where your layer manager comes in play. We have the viewport layer, and it's set to not plot. these viewports are on that viewport layer. So when you go to print, you won't see these squares. If you want to see them, then that's okay too. But oftentimes you don't want them to be displayed. So very briefly here, model space contains the drawing geometry or the model. Paper space contains what will be printed out on paper. Making a design in Autocad is more than just drawing lines and circles. It's a complex process that has been developed so that we can create complex designs. One of the keys to efficient CAD work is to organize your data. A model space is meant to be a three-dimensional area in Autocad and a two-dimensional area in Autocad LT where you can draw and create your design. Your design needs may not include three-dimensional models, only two-dimensionals, and that's fine. But regardless of how many dimensions your design requires, the model for it belongs in model space. Let's look at some examples. Open up the dimension example drawing. This is an example of a two-dimensional model. Now go to model space. The only thing in here is the line work. If we do a zoom extents, that's all that's here. All of these layers are turned on and thawed, so we can see everything that's here. We have our line work. That's it. Now let's go to paper space, and you can pick any of these tabs. The only thing here are our dimensions. I can't pick any of the line work because they're in a viewport, so there's no line work here. This is a very simple example, but it's very clear. And sometimes the lines between model space and paper space can become blurred, and it's okay. So let's go and make a new layout tab. I'll show you how to do this. You come down to your tabs, right-click, and you can right-click on any of them and select the New Layout button. And it creates a new layout. It's right here. It puts it at the end, and it's called Layout 1. Click it to activate it. Now, when you create a new layout, a viewport is automatically generated, and it's created on the current layer. Well, let's move that to a viewport layer. That will let us manage the viewport. Now, one thing you can do, if you come down to a tab, let's look at this one that has all the dimensions on it, right-click on it, and we showed you how to do a new layout, but you can also copy a layout. If you hit Move or Copy, and select the Create a Copy option, let's move it to the end, and it called it Dimension 2. Now it literally made a copy of the Dimension tab. They're identical. Now that's a great trick to use, especially if you have a title block already filled out. Any information that's in it, a viewport that's set to a specific scale, all of these things are very important, and it can save you a lot of time because many times we need to create a similar drawing, but yet is a little bit different. Once you're created a viewport, you can double-click inside that viewport to activate temporary model space. So now I'm working in model space, even though I'm in paper space. And you'll note that when I move my crosshairs out of that viewport, I just get the little arrowhead instead. I can't draw over here. I can only draw with what's in here, and it's in model space. I can't select these text objects. I can edit this drawing all that I want to, but I can't edit my text. Now the viewport is locked, as you can see here. And we'll talk a little bit more about that later on. But I'm now in temporary model space, or some people call it floating model space. To get out of it, I double click somewhere on the side, or these tab buttons right here, I can click and it will activate a viewport in my layout paper space tab. And if I click it again, it brings me back into paper space. Now, when we're in a viewport, we can freeze certain items. Double click in the viewport to activate it. Pick the freeze, layer freeze, and let's freeze those center lines. So see, I don't need them. Okay, now let's say that we needed to make a drawing that showed just the outline of the bracket so that someone can go find their steel plate and cut it out for us. And then once that's cut out, we'll give it to someone else and they can burn in the holes for us. We can activate this viewport. We can freeze the holes, freeze the center lines, enter, go back to paper space, use the delete command or erase, and get rid of these dimensions that we don't need that show where the holes are. And with just a couple of clicks and a very quick copy, we've created two different drawings from the same drawing. That's what viewports can do for you. And that's why it's important to put your model in model space and your text or your annotations in paper space. Now I can click on one of these tabs, hold it, and I can drag it and I can reposition it in here, similar to using like a spreadsheet. So now I can quickly get to either tab. And I've created a whole new drawing, but I'm using the same exact line work. As we have discussed in several sections and chapters, model information goes into model space and annotations go in paper space. In order to annotate anything, we need to have the model visible in paper space. That's done through viewports. Think of a viewport as a window to model space or a photograph of that model that you can label. Since each viewport is its own photo, we can do anything we want to them, and they won't affect anything else, not the model nor the other viewports. You use those viewports to arrange the views of your drawing on a sheet. You can move and resize layout viewports, and you can use the different layout viewports to have more control over the display of your drawings. For example, you can freeze certain layers in one layout viewport without affecting the others. Let's open up the ice rink example file. Let's create a new layout tab. Right-click, and then select New Layout Options here. And it called it Layout 2. To change its name, you can right-click on the tab and pick the Rename option. Let's call it Rinks. Press Enter. Now we know which one we're working with. When a new tab is made, a default viewport is always created. You can use that one if you'd like, or you can create one from scratch. We're going to use this one, but then we'll make an additional viewport later on, because you can make many different viewports. A viewport is an object just like anything else. It can be moved, copied, deleted, rotated, etc. Let's move this one right now. We're going to move it to the left, and then we're going to resize it so that it only fills up about half of the drawing. So just select it like you would any other object and grip edit. Just stretch it over. Now in this viewport, you'll see this hard line. That's the edge of the paper. Whatever size this drawing is set up to right now, and we'll talk more about that later on in the next few sections when we talk about printing. Now the dashed line is the actual printable paper size. All printers are only able to print so far in on a sheet. It needs an edge to hold on to, and it can't print the full size. And so this dashed line is showing you where you can print at. So that's the size that you want to make sure you stay in. Now a good idea is also to make a border or a title block so that you can put it on your drawings. But for this example right here, I just want to show you how to create a viewport and how to manipulate it. Now let's activate the viewport. Do that by double-clicking inside it. And now let's set the scale to a 1 to 100. Now how do you do that? Well, I can zoom in and out, and it's actually changing the scale. I can pan around, and this changes the view. Doesn't change the model any, but it changes how I see that model in my viewport. If I double click, I do a zoom extents, and it fills the line work inside my viewport. Now if I come down to the bottom right, I have two different things that are very important. This is the lock unlock a viewport. Right now the icon looks like an unlocked lock. That means I can pan around or zoom in and out in my viewport. So be careful. If you are working in paper space, you can move around, you can zoom in, that's fine, and it won't change the view. But if you activate your viewport by double clicking in it and I start zooming or panning, it will change my view. But if you lock it, Now I'm inside the viewport, and I can zoom out or zoom in or pan, and it won't change my view. It locks the view. So once you get your view set, lock it. Well, let's give this an actual scale. Click here, and now you're going to have scales available to you. I'm going to click a 1 to 100. Now I'm locking the viewport. So now I can zoom in, I can zoom out, I can pan around, and I won't mess things up. You won't know how many times I've worked in a drawing, and other people too, and they activate a viewport and they need to zoom in and they've just screwed everything up because someone didn't lock the viewport. Maybe it was them, maybe it was someone else, who knows. But make sure you lock your viewports. Get the scale and the view set up the way you need it, and then lock it. If you need to change it later, you can always unlock it and move it around accordingly. Now, let's create another view, because this is a good view of the entire ice rink, but we want to zoom in on something. We want to have a little detail. So let's make a new viewport. Go to the Layout tab on the ribbon, and let's go to the Layout Viewports. You have a couple of options. If you have a closed polygon or closed polyline, you can select that with Object, and it will create that shape of an object as a viewport. You can create a polygonal one, which works just as fine, or you can just create a basic rectangular viewport. Let's pick that one. Just pick one point, then pick another. There's your viewport. Let's zoom in towards the entrance of the rink because we want to make a view that shows the entrance. Now let's set the scale at 1 to 30. And you can make any adjustments you want to your viewport by panning around, and now lock it in. Now you can also grip edit this as long as you have the scale the way you want it. Turn off my O-snaps, and I can reduce what is visible. I can also move this around to wherever I need it to be. Very useful. And we can add some dimensions. If we go to the Annotate tab, I'm going to turn my O-snaps back on, and I'm going to start dimensioning my drawing. Nothing crazy here, just some basic overall dimensions so that we can kind of get an idea of how big this entrance is going to be. And now we can compare it to the overall size of the rink. And as you can see, though, even though our views are at different scales, they're still showing us the exact same dimensions. "21 feet, 21 feet. But we're at two different drawing scales. 77 feet for that overall number. So that's pretty cool. And that's the point to having multiple viewports. It's also the point to having your model in model space and your annotations or your dimensions in paper space. Because if I were to put dimensions here in model space, they're going to show up when I go in paper space. That line is showing up right there, and it's not set up properly to dimension in model space right now anyway. But the line also shows up here. And if I have multiple tabs in my file, it's going to show up there as well. See, but this dimension here is in paper space. It's not showing up anywhere else. Now, if there is something that you want to show in all viewports, put it in model space. So if you want to label this as Rink 1 and Rink 2, you can put that text in model space and it'll show up everywhere. And then that type of thing is okay to do. Now, there are other ways to edit a viewport as well. If you select one, come to the Properties panel. See, I told you in the very beginning that I leave this Properties panel open all the time because there are so many different uses for it. We have our regular general settings for color, line type, layer, etc. Basic geometry. And now we have our miscellaneous settings. Is the viewport on? Yes. I can turn it off. So if you need to show a drawing real quickly without a specific view in it and print it out, you can turn it off real quick without losing any of your work. You can clip a viewport. You can lock it or unlock it. You can change the scale. We can't now though because it's locked. So if I unlock it, I can now change my custom scale. Let's say instead of 1 to 100, it's 1 to 50, and it zooms right in. Because we're using associative dimensions, they follow. I can change some visual styles, some shading, and other things that we typically don't need to use unless we're doing some 3D work and rendering in Autocad. Press Escape to deselect that viewport. Sometimes you have a hard time selecting the proper viewport. For example, if this viewport overlapped and I wanted to click here, well, but that's not the one I want. I can come over here and sometimes it can get hairy. Well, here's a little trick. If you press Control and R at the same time, it'll toggle you through the different viewports in that layout tab. So you just pick the one you want and go. Because if you pick this button here for the paper space, it'll just activate on one of the viewports that are available, and it may be the wrong one. So you either just double click in there or hit Control R. Let me show you another example. If this viewport is completely inside the other viewport, which happens sometimes, and I click right here, how do I get that viewport? See, you can get stuck real easy because I'm inside the viewport. So if I click outside and then I click inside again, I'm not getting the right one. So I press Control R and now that one's activated. Sometimes you need a viewport that's not a rectangular shape. Well, you can go to the Layout tab and you can create a polygon viewport. Now this uses essentially your P-line command and you can make any shape that you want. Close it up and there's your viewport. So you can get some really odd shapes, or if you need something that's really weird that's not a rectangle, you can get that shape in here. If you use the clip command, you can select your viewport, press enter, and draw a new shape with a polyline, and it clips it out for you. That'll save your settings, that'll save your dimensions in the right place, and all of that. Just follow the on-screen instructions. We use Autocad and other software programs to help us create construction documents more efficiently and more accurately. That means that whatever we draw or design on the computer must have a way to be shown on paper. That's where printing or plotting comes in. Autocad calls printing plotting and plotting printing, so they both go hand in hand. It comes from the way lines and arcs were once drawn on the board. They were plotted. A drafter would plot points and connect the dots with a straight edge. Then the term stuck, especially when pen plotters were used. Nowadays, we typically use inkjets and laser printers for most of our plotting or printing needs. So believe it or not, printing and AutoCAD drawing can be very difficult to get exactly right. The reason is that there are so many different settings involved and ways to plot that it can get confusing. Also, the terms printing and plotting are nowadays synonymous with each other. So if I say one or say the other, I mean the same thing. We're trying to get our AutoCAD drawing on paper. This video will stay away from settings for specific printers and try to focus on the AutoCAD settings, because the printers throw in a whole nother set of variables. Most of the AutoCAD settings will be the same regardless of the printer type and model, but there will be some variances for each printer and plotter. You kind of have to play with them until you get it right for your device. But there are four main settings to keep in mind when you're printing a drawing: the printing device itself, the paper size, the area to be printed, and the scale to be printed to. So let's look at an example file here. Let's add some color to the mix. go to the Chapter 13 section, and let's open up the color wheel, colorwh.dwg. Now this file here was put together by Autodesk themselves, and it demonstrates the many different colors that are available to you in AutoCAD. Now if you have a black and white printer, it's going to only print black and white, and that's fine for what we're doing now. But if you have a color printer, you may want to see it. And if you get a new printer, a new color printer, and you want to test it out to see how well it handles all of the different colors, save this file and print it. Use it as a test print. It has two different main tabs on it, the true color that we just saw, and then the AutoCAD color index. This might be an interesting drawing to print out and hang up in your cubicle or your work area, so that if you want to see what a color is going to look like, you can use this chart. It may or may not make any sense right at first, but it actually does. These colors here are your first 9 main standard colors. The wheel here has the different variances on it. If you start with the number 864201357 and then add 1 to it for this area, so this is color 19, 17, 15, 13, 11, etc. You get the idea. So these are pretty cool. There's a lot that you can do. Now, you can print from anywhere in AutoCAD and at any size, meaning that either model space or paper space can be printed from. That's fine. It's suggested that you set up your drawing to be printed from paper space though, and I suggest that too. There are several ways to start the printing process, just like with everything else in AutoCAD. You can press Control P. That's a Windows setting. That will open up your plot window here. And it tells you what you're plotting out or printing. True color. That's the name of the tab. You can also type in the word plot. You can type in the word print. You can come up to the quick access toolbar and click on the plot button. You can come here to the application manager and go to the print button. And you can plot, batch, plot preview. We'll look at some of these a little bit later. But you can see what I'm talking about here. AutoCAD calls it plot preview, edit plot styles, even batch plot or plot, but it starts off with the print button. So both words or terms are fine for what we're trying to do. Which way is better to start the plot command? I don't know. I'll typically do Control P because I'm a keyboard guy, but you can do whatever you want. All of it gets you to the same spot. Another way you can also do it is to go down to the tab that you're on, right click and pick plot. So you have so many different ways to print from AutoCAD. It's crazy. So as you can see in our plot window here, there are several different settings. This button here that I even clicked just by habit expands out and gives you even more control. So you may or may not want to do that. These are some more advanced settings. I typically leave it open because I'm at work. I'm constantly messing with these settings because I need different things to print. But that's all up to you and how you're going to print and what you need to print. Okay, so we start off by a lot of different things. We see here with the printer or the plotter. This is what you're printing to. You can print to several different devices. These are the ones that are available to me. I can set it to print to none, but then it won't print. But the reason you might want to set it to none is if you're sending your CAD file to someone else who has a different printer. Because when you open up a CAD file and it has a wrong printer or one that's unavailable to you, you get this error message that says, hey, I can't find the printer, I'm freaking out, I don't know what to do, So that's one reason why you want to set it to none. If you have different programs on your computer, like I have Snagit, OneNote, PDF Writer, etc., a lot of these things you can print directly to their file format. If you have a fax machine, you can print it to fax. This is my main printer here. That is an 8.5 by 11 black and white and color inkjet printer. You can have your default Windows system printer, whatever that may be. And it comes with AutoCAD here, this DWF, DWFX, PDF, and JPEG and PNG. That means AutoCAD naturally can print to these different types of file formats. A lot of times you'll print to a PDF or a DWF because you have to send them to a client for review who doesn't have AutoCAD and all they want is the drawing. Or a lot of times if you have to submit work for permits to government agencies, they'll require a PDF or a DWF. Those things are great for discussion purposes, and it gives someone a hard copy so that they don't have to mess with AutoCAD. Maybe they don't know how, maybe they don't even have access to the software, but you can send them that type of image file. So regardless of the type of drawing that you want to print to, if it's paper or if it's electronic, you have a lot of choices that come with AutoCAD. So that's your first pick right there, is to find your printer. Let's print to a PDF. And now every printer that you make will have a properties button. You can click it, and again, you see there are more and more properties to choose from. Paper size, graphics settings, etc. You can even change media types. So if you have a printer that really needs to print to a Mylar or a vellum instead of a bond type of paper, you can change those types of settings there. I know you may be feeling overwhelmed and you want to just print, so we're going to try to just get to it.